Hi, my name is Simran, and today I'll be presenting on the topic of renewable energy. I will be discussing some major resources of renewable energy and looking into two major issues of hydroelectric power and fuel cells. Just to start out with the definition of renewable energy is a resource which can be used repeatedly and replaced naturally. Renewable energy almost never runs out, and we can see examples of this through solar energy, oxygen, fresh water, and biomass, and many other sources. There is another alternative source of energy known as non-renewable energy. And the difference between a renewable energy and non-renewable energy is that a renewable energy source can be replenished easily, and this is because they're derived from natural sources such as sun and the wind. I apologize if you're not able to read some of the written words above. I'm not so good with the technical editing stuff. Some of the major examples of renewable energy sources are solar power, wind power, hydropower, geothermal, and biomass. So solar energy is a renewable energy source as it uses sun's radiation to reach the earth. The energy is converted into other forms of energy such as heat and electricity. Sun is a major source as it's constantly producing fuel. It produces thermal energy through the process known as nuclear fission. Hydrogen and helium atoms are constantly slamming together, and hydrogen atoms form helium. And this process has been going on for millions of years. We can see example of solar energy through solar power towers. Another source is wind power. Now, winds are caused by the uneven heating of the atmosphere by the sun. It's also because of irregularities of Earth's surface and also due to the rotation of the Earth as well. Now, water is used for hydroelectric power, and we can use water in turbines as it powers them, and then hydroelectricity is formed and power is eventually converted into electricity. This here is the hydrologic cycle, and it shows how sun evaporates water from bodies of water through a process known as evaporation. And as the water goes up and form cloud and drift over to the land, it eventually precipitates in the form of snow, rain, and some of the water molecules are released at a higher elevation. Why? Because they create a potential energy as they run down and towards the oceans. Eventually it turns into kinetic energy, and this can be done through a small insertion of even a hydroelectric plant in the middle of a field can definitely generate that electricity. Moving on to hydropower, also known as hydroelectricity. It is definitely a fast-moving water. It most likely relies on fast-moving waters in large rivers and oceans. It pretty much converts energy from flowing water into electricity. It's considered a renewable energy source because the water cycle is constantly being renewed by the sun, and it mainly relies on water. Like I said, most likely fast-moving waters in large rivers because it's definitely going from higher point, and it converts the force of those waters in higher points into electricity as the generator's turbine spins. Geothermal energy is heat from the earth. It's clean and sustainable, and geothermal energy can be used directly to provide heat and sometimes indirectly to produce electricity. We can see geothermal energy on smaller scales like heat pumps and systems in the buildings in our homes. Biomass is also another source, renewable energy source, as its organic materials are composed of straight from the sun, and it can be used to regrow a lot of things in a very short period of time. So it's very organic and natural. This figure right here just shows how renewable energy sources from many of its sources is an incredible way to power, heat, and fuel our country. And we can see how each type of renewable energy source, whether it's hydro to solar to biomass, all contributes in different way towards electricity, heat, and fuels. Renewable energy definitely has its pros and cons. It definitely does not produce any greenhouse gases through solar, wind power, or geothermal energy. There's definitely high production electricity through hydropower, and it's a very limited effect of any kind of negative effect on the environment through any solar energy. There are downfalls to it because wind powers normally do require large, extensive land uses. They can also harm any bats and migrating birds through those turbines. Solar energy components like the power towers are definitely an expensive investment to install. And also, there definitely is a small damage to the environment through hydropowers, because when we build those dams, it can definitely change water regularities, its chemistry, and then temperature as well. It can definitely cause harm to some fish and other aquatic species as well. One of the issues that I'll be talking about is hydroelectric power. Hydroelectric power, basically, in basically the purpose of it is to produce electricity from generators that are driven by turbines that convert potential energy of falling or fast flowing water into mechanical energy. Hydroelectric power plants are usually located in dams and rivers. It rises the water level behind the dam, and it also creates as high as the head as feasible. There are in some areas powerhouses that are constructed, and in other areas hydroelectric power plants are constructed so that people can take advantage of those, especially with the rise and fall of the tides. Hydro plants normally produce electricity using turbines and generators, where mechanical energy is created when water spins through rotors on a turbine. This figure right here shows different components of that, and it shows how this turbine is connected to the electromagnetic generator, which produces electricity when the turbine spins. Two main components of electricity productions is dams and rivers. Now, dams normally utilizes the potential energy from dam waters to produce electricity. Run-of rivers normally uses turbines and generators, but rely on natural water flow. There are definitely advantages and disadvantages of the hydropower itself. They are normally cost-competitive form of electricity, and they're a very reliable source if you compare it to any other source. And they definitely are very helpful in terms of flood control, and it provides a water supply as well. There are a few disadvantages, such as I mentioned earlier, aquatic life is definitely harmed, and there are definitely changes in wildlife habitat, and they're all not completely free of greenhouse gas emissions as well. So the next topic is hydrogen and fuel cells. Hydrogen is definitely a very large source of fuel for our future, and it's a combustible gas that can be reacted with oxygen, and it gives off energy as a result, and the only product of that remains is water. It's a very clean source of energy, and as a gas, it yields lots of energy per gram compared to other fossil fuels. This is basically a basic redox reaction of hydrogen in a fuel cell, and we can see the breakdown of hydrogen and through oxidation half reaction, and at the end product remains just water. And in a fuel cell, there is a hydrogen which is able to give up its electrons by forming hydrogen plus and 2 electrons as a result. And now fuel cells are pretty much just the purpose of fuel cells is to convert chemicals such as hydrogen and oxygen into water in order to produce electricity. A great example of this can be seen through a battery, because a battery is known to be an electrochemical device. It converts the chemicals stored inside into electricity, and now the thing about the batteries is they're eventually going to run out, and or they're going to die. And what we do is we either recharge it or we throw it away. But fuel cells are a little bit different. They are constantly allowing chemical flow into the cell, so it never goes dead. And as long as there is flow of chemicals into the cell, the electricity flows out of the cell as well. A hydrogen fuel cell is definitely an electrochemical cell that uses spontaneous redox reactions to produce current that can do work. And this right here is a fuel cell, and shows how the whole process takes place. So the hydrogen flows to a platinum catalyst, which is connected to the anode. Molecular hydrogen is dissociated to atomic hydrogen on the metal surface, and the atomic hydrogen is oxidized this way. The protons normally travel through solid electrolyte, and molecular oxygen is normally reduced at the cathode side there, and is combined with protons, and this way water is formed. There is definitely a problem with a hydrogen and fuel cells as a source of hydrogen. It's a problem because the quantity of hydrogen in the atmosphere is very low, and it can be definitely very crucial as well. Now, just looking at renewable energy as an overall energy source, there is definitely a higher upfront cost for sure. And while we can rely on it to save money using these such sources, it's definitely going to cost us high for technologies that are needing to be built for such energy. There are other problems like geographic limitations and also storage capability as well. But if we look at it at the end of the day, there are definitely more positive aspects than negative aspects. And renewable energy is definitely going to promote a more clean, natural, and a more sustainable environment for sure. And these are my sources. And thank you for watching.